of fuzzy linear programming. And now uh, it was supposed to have some examples for every state that you have learned before. Okay. The first example is related to the first structure of fuzzy linear program. In this example, we are going to convert the fuzzy linear programming to the crisp linear programming. Maximum z equals 3x1 plus 2x2 subjected to two constraints. Is the first constraint, this equation 2x1 plus x2 is less than fuzzy, the right hand number 4. And the second constraint x1 plus 2x2 is greater than. In the first fuzzy state is greater than 6. x1 and x2 are non-negative. Okay. In the first place, we must solve this linear programming without considering the fuzzy sign. For example, maximum, less than, or greater than. In the structure of crisp linear programming, when you solve this model, this linear programming without considering the fuzzy conditions, x1 star equals 0, x2 star equals 4, and z star equals 8. So, as I have declared before, you can define z upper or z lower for the objective function to obtain the fuzzy linear programming model, and it is necessary to present z upper for this, and we can consider z upper a few more than this number. For example, 9 is suitable. And in this structure, we have this condition. As you remember, in this plot related to the maximizing objective function, you define z upper and z lower, and you can accept a few violation from the objective function, optimal objective function value, considering fuzzy condition and using a membership degree. Okay. The new model, the crisp model, like this: maximum lambda, and for this equation subjected to you must in the first place convert this equation on the right hand side of this equation. Expression 3x1 plus 2x2 must be multiplied in the negative value 3x1 minus or negative 3x1 minus 2x2 is less than minus or negative z upper, and this is our z upper. Okay. And there are allowable deviation or tolerance for every equation. For example, for the objective function, allowable is equal 1.5. For the first constraint, tolerance equals 1. For the second constraint, tolerance equals 1.2. Okay. Lambda must be multiplied to the P1 for the objective function. 1.5 lambda plus this expression minus 3x1 minus 2x2 is less than as you remember, we must add the allowable deviation to this value. I mean 1.5 plus minus 9. For other constraints, for the first constraint, lambda plus 2x1 plus x2 is less than 4. But we must add it to the 4 this value, allowable deviation 1 plus 4. For the last constraint, 1.2 multiply lambda, but you can change this inequality to the standard inequality with multiplying negative. Okay, minus x1 minus 2x2 is less than this value, 1.2 minus 6. And in continuing of this model, you must write the sign of x1, x2, and lambda are non-negative variables. Okay. Now, in this part, we can write or code in the GAMS software that I said previously. I hope you are familiar to this software. Okay. In the first place, we must define the variables. Variables x1, x2, z as objective function, lambda as objective function, and z1 instead of a crisp objective function, the expression on the right hand side of objective function in the certain model, and positive variable x1, x2, and lambda. That's enough. And for equations, objective function, constraint 1, constraint 2, constraint 3, and we want to know the value of expression on the right hand side of the main objective function. So we must define constraint 4 for this part. Objective function is defined like this: z is equal, excuse me, semicolon, z equals lambda, and constraint 1, first constraint, as you see, 1.5 lambda, 1.5 multiplied lambda minus 3 multiplied x1 minus 2 times x2 is less than the right hand side. I write exactly all numbers: 1.15 minus 9, semicolon, and C2 lambda plus 2x1 plus x2 is less than 1 plus 4, and third constraint 1.2 multiplied lambda minus x1 minus 2 times x2 is less than 1.2 minus 6. And the last constraint related to the main objective function, the expression. So for writing this part, in the first place we must define the variable for the left hand side of the equation. Z1 is equal to the main 3x1 plus 2x2, as you see. We must program or software calculate this value for us in the structural crisp linear programming model after converting to that from the fuzzy linear program. Okay. 3x1 plus 2x2. Now we can close the software with these syntax: model fuzzy linear programming, all parameters and variables, solve fuzzy linear programming using linear programming, maximizing z as objective function, new objective function, or lambda instead of the z. Semicolon. Display related to presenting the values for every variable. For example, x1, x2, z1 also, and lambda or Z. They are similar to each other. Okay. Oh, there are many errors. Lambda up to multiply. And also there are errors. Oh yes. Unfortunately, I've forgotten the sign of multiply. Okay. As you see, the objective value equals 0.7 approximately. Now this means that lambda equals 0.7. 70% or membership degree is equal to the 70%. And other variable, for example, Z1. Okay, as you see, the Z1 equals 8.5 approximately, with deviation of half, 0.5 more than the optimum objective function or optimum value for the best solution of objective function in the certain model. Okay, and this is lambda. Also you can see on this part, for example, Z is 9, Z upper is 9, and for example, Z lower is 7.5, and your objective function now equals to, in the fuzzy linear programming, equals to approximately 8.5 with approximately lambda equals 70%. Okay. And for another example, the second stage, for example, maximum Z equals TFN, triangular fuzzy numbers 4, 5, and 10 as coefficient of decision variable, first decision variable, and negative 2, 3, and 7 as coefficient of the second decision variable, subjected to 8 x1 plus 3 x2 is less than 24. And also we have other constraint, minus x1 plus 2x2 equals then 10. x1 and x2 are now negative. Okay. But this model previous has been solved with this structures. For example, there are three objective functions. As you remember, we can differentiate the single objective function, single fuzzy objective function, to three crisp objective function in the first place. Okay. C pessimist, C moderate, and C optimist. C pessimist, C moderate, and C optimist for the maximum objective function. There are three objective functions. Mean Z1 equals the difference between Cm and Cp. 5 minus 4 x1 plus 3 minus minus 2 multiply x2, and the second objective function equals 5x1 plus 3x2, and the third objective function equals 10 minus 5x1 plus 7 minus 3x2. And we have previously solved the three models, three crisp models, crisp linear programming, individually with every objective function subject to the main constraints. And we have obtained the solutions. For example, Z upper for maximum Z1 and Z lower. Z upper equals 28.3158 and ZL equals 0. For others also we have obtained these values. ZU equals 21.1579 and Z lower equals 0. And for the third objective function, ZU equals 26 and ZL equals 0 also. And for the final model, maximum lambda subject to three inequality for three objective function. For the first, you must obtain the difference between Z upper and Z lower for the first objective function, and this equals 28.3158 lambda since the objective function must be minimized, we have this equation plus x1 plus 5x to y is related to this part. x1 5x2. Okay, is less than z upper. The object function must be minimized that the value of the right hand side equals to z upper. What does z upper? 28. This is the first inequality or constraint for the converted certain linear programming model. And for others, we have lambda minus, because the second objective function must be maximized, and this must minus subtract from this function, this expression, 5x1 plus 3x2. Is less than negative z lower. Z lower in all objectives, all models have been obtained 0. Minus or negative z lower is 0. And for the third, 26, excuse me, 0.639 lambda minus, this is maximum also, 5x plus 4, 5x8 plus 4x2 is less than z lower is equal to the 0. Considering the main constraint, and minus x1 plus 2x2 less than 10, x1, x2 and lambda all are now negative. This is the crisp model, and this is ready for solve. Okay, we will continue our discussion in next session for two other examples, for two other states.